Now we have the next presentation. Thank you.
Thank you very much. Thank you very much for introduction, Mr. Chairman. Ladies and gentlemen, good afternoon. Let me present a small contribution on the modeling of the concrete spatial variation of properties. It's prepared in cooperation with my PhD students, Tuan Ladutz and Petr Lehner, and my name is Petr Konečný. And I'm working at the Technical University of Ostrava, Czech Republic. The motivation behind the work is modeling and the analysis of the chloride ingress into the concrete. And this has an impact on the durability of the concrete because of the corrosion induced by the chlorides from de-icing agents penetrating to the level of the reinforcement. And there are several approaches to analyze the effect of chlorides. And currently there is a availability to analyze even 2D profile of the chloride content in the concrete via laser-induced breakdown spectroscopy. And this contribution is not oriented on the experiments, it's oriented rather on the testing of the modeling. We are not possessing that capability. We are using the drilling and making a powder and then a chemical analysis, which is quite time-consuming, and you don't have this heterogeneous properties over the 2D profile. However, in case in some future time we will have the ability to have the scan like this, it would be nice to have the model that can be capable of reproducing the physical experiment. So we were trying to evaluate the possibility of the application of the probabilistic random fields to model the heterogeneity. So if we have the concrete, which is the structural material, it can be, for example, on the highway bridges, and this is exposed to the, for example, winter de-icing or the marine environment, and the structure the structure is exposed to chlorides, they penetrate, and we can, in simplified way, model the chloride penetration by the second Fick's law of diffusion. And when the concentration of the chlorides at the level of the reinforcement is too high, then the corrosion starts to propagate, and the initiation period is exploited. So this is a sample of the 2D model built in the MATLAB that we use. And this is a surface of, for example, bridge deck. So this is the vertical cross-section of the bridge deck. And for example, this is the picture from the US highway bridge deck, and the concrete is prone to cracking. So this model can handle also the ingress of chlorides via the cracks to some extent. And those two pictures are illustrative. The chlorides concentration increase at the reinforcement level for the time, and then here is the other way around. We compare when the chloride concentration is at the unacceptable level and the corrosion propagates. So this is the illustrative picture of the model that we have, and currently it can be probabilistic, but the material property, diffusion coefficient of chloride, was considered to be homogeneous over the area, and the probability was added via Monte Carlo in repeated simulation steps. And we tried to evaluate the possibility of introducing the heterogeneity, and we are here at the conference for fatigue, and for example, in case of a fracture process in concrete, the lattice models for the structural mechanics process modeling were introduced, and they were even complemented with the probabilistic approaches and random fluctuations, or other approaches for the heterogeneity multiphase model. This is built even for the chloride ingress, or Wang tiles may be applied for the special variations. And we will focus on the random field application that we adopted from the group of Eliáš and Vořechovský from Brno University of Technology. And here the variation of material property over the cross-section is controlled by autocorrelation function, where in the particular distance between two points, the correlation length plays the role, and this explains how is the correlation between the points based on the distance, describing the variation. And then if we randomly generate the property over the area, in order to get the spatial variation controlled by autocorrelation function, the Karhunen-Levé expansion generates the random field. And here I would like to point that it's a probabilistic approach in two levels. One level is in simulation step, you generate the random property. So if you have 1,000, or let's say 10 simulation steps, you have 10 different samples. And throughout each of the samples, you have also correlation on the cross-section. And here you can see one Monte Carlo sample. Here is the homogeneous approach, material property, diffusion coefficient of concrete, of chlorides into concrete, and this is the variation of the diffusion coefficient controlled by the autocorrelation. This is basically a random field. So we try to enhance the 2D chloride penetration model built in our collective, try to describe the heterogeneous property of concrete, and initially tested the random field for chloride penetration. For that test, we used the finite element analysis, and the boundary conditions were simplified, so the chloride were approaching from the surface only. So we have not dealt with the crack effect here. And it is the transient analysis. It changed over the time. And spatial variation is introduced via random field. And the Latin hypercube sampling is used to generate the population. And in order to speed up the process, the expansion optimal linear estimation method was used based on the authors from based of the implementation of the authors from the Brno University of Technology. And we used one sample of homogeneous and one sample of heterogeneous for comparison. Here are the random input. Here are the input parameters. So material property is diffusion coefficient. Since the concrete improves its property over the age, over the time due to the chemical process of hydration, here's the aging factor here, and variation coefficient of the material property is given here. And what is most important, correlation length that controls the spatial variation was adopted based on the suggestion here. So this is a result of the simulation. To models. One is the homogeneous, the other is heterogeneous. Concentration of the chlorides is the loading from the surface. Here, the dashed white line represents the possible level of the steel reinforcement that is prone to corrosion. And this is actually the height or the depth where we analyze the concentration of chloride. And here, in homogeneous model, you can find that the lines are parallel. And here in the heterogeneous, you can find out that the isolines are not parallel. It means there is to some extent heterogeneity going on. But if we go back to the initial picture, here we cannot go to mesoscale. We cannot model the aggregate effect and the paste effect. So in current implementation, it is not what we have expected for us. You know, these are the results of the concentration of chlorides at the level of the reinforcement, the homogeneous approach, and this is the non-homogeneous approach. And these three lines that basically overlaps each other are minimum from the simulation, maximum, and the mean value. So we can see that this implementation of spatial variation has basically no significant effect. You know. And let me conclude. The initial attempt to prepare the 2D chloride ingress model considering spatial variation was presented. The heterogeneity was addressed to the limited extent, and it can address rather than the aggregate and paste difference, the change of the properties over the aggregates, over the clusters of the aggregates and the paste. And in order to replicate the laser-induced breakdown spectroscopy, the higher diffusion gradient would be necessary to address the difference between the aggregate and the paste, and or the multi-phased approach shall be adopted. So, thank you for your attention.
Thank you for your nice presentation. We have some time for questions or comments. Some questions, comments? I have a question for you. Are you going to plan some further development in your research on this topic? What type of?
Definitely yes. And so definitely yes. And it is given here. First is the possibility to put higher diffusion gradient into the spatial variation, or to use the multi-phase approach. It means that, for example, the aggregate will have zero ability to penetrate for the penetration of chlorides, and we will concentrate only on paste. And then within that paste, we can use the spatial variation and neglect basically the aggregate. This is a possible way how to continue. Thank you.
Okay, thank you. Other questions or comments? No? We have to wait 2 minutes for the next presentation.